Okay, this is solving exponential equations a little more challenging. And so I just have 3 problems on this worksheet. And so the thing about solving exponential equations is we are in a class called pre-calculus, which means that we were getting ready for calculus. And so the big deal in getting ready for calculus is that you have to be really good at algebra. And so to ensure that you guys are good at algebra is I'm going to restrict what log bases you can use so that you ensure that you use algebra to solve these. So you may use the natural log, ln, and you may use the common log base 10, just log. Those are the ones that you would see on the face of any scientific calculator. So I know we have calculators that you can put in any base that you want, but my job is not to make sure you know how to press buttons, but to know you know the algebra. So I restrict the use of logs. We can only use natural log or we can use log base 10 to solve these. So when we are given this exponential equation, we recognize that this is exponential because the variable appears in the exponent right here. So exponential. What do we need to help ourselves solve this? We need to employ an inverse. And so the inverse to an exponential equation is a log. Now I am not allowing us to use log base 7. We have to use log base 10 or log base e. So either one would do. So I'm going to choose natural log for this particular case. And the next one I'll do log base 10. I'm choose natural log to approach this. So I'm going to apply the ln, the natural log of 7 to the x plus 2 is equal to the natural log of 231. Okay, now, why does that help? Well, it helps because once you've introduced a log, then you get to use the log properties. And the one that's very helpful for us is the power rule, which means we can throw the power in the front. So this becomes x plus 2 times the natural log of 7 is the natural log of 231. Now, if I want to solve for x, I have 2 choices. They're both equally fine. I could divide both sides by the natural log of 7, or I could distribute this. Now, when I think about this, if this becomes too much, I imagine something simpler that's very much like this. What if I was solving this equation? X plus 2 times the number 7 equals 231. So I imagine, what if it did not have a logarithm involved? How would I approach this? Because this is a linear equation, and so is this. This natural log of 7 is not a whole number 7, but it is another real number, so I can treat it the same. I can distribute the 7x plus 14 is 231. I could do that, or I could divide both sides by 7. Either way would be fine. I'm going to choose to distribute this. So I'll get x times the natural log of 7 plus 2 times the natural log of 7 is equal to the natural log of 231. So basically I have the same thing here. If I was solving this equation, I would isolate my x, and so I would do that by subtracting 14 from both sides. So I'm going to do the same thing here. I'm going to subtract this 2 natural log of 7, the term that does not have an x in it, from both sides to isolate my term that does have the x in it. Is the natural log of 231 minus 2 times the natural log of 7. So now I have all of this. X times the number equals all of this. If I had x times a number, let me think for a second. That would be, I think this is 217. I just sat there. 30, yeah, I think that's right. If I had x times a number equals another number, over here I would just divide both sides by 7 to isolate the x. Okay, that's not what I have, but I have kind of the same situation. I have a number times x equals another number. And so all I'm going to do is divide both sides by the natural log of 7. So x equals to this. This is the exact solution. So if I say, what's the exact solution? That's the exact solution. What is the approximate solution? Okay, where did my calculator go? Hang on just a second. We're going to get the approximate. Oh, here we go. The approximate solution would be for me to put this in my calculator. Now, let me just say, it could be that you have the correct approximate answer, but it looks a little bit different. So real quick, what if I had done it this way, just so you can know the different ways it can look, because you can use log properties to make it look different ways. So what if at this point, let's just say, what if I went a different route here, right here? What if I said, let's divide both sides by the natural log of 7. So if you did that, you'd get x plus 2 is equal to the natural log of 231 divided by the natural log of 7. And then how could you solve for x? You could just subtract 2. The natural log of 231 over the natural log of 7 minus 2. This is also an accurate approximate answer. So when we put this in our calculator or this in our calculator, we'll get the same approximate answer. So let's just see. Let me do this one first. You would say parentheses, natural log of 231, close parentheses, minus 2 natural log, it opens up a parentheses, put in 7, close your parentheses to close your log argument, close your parentheses to close your numerator, and divide by the natural log of 7. And when I do that, I get 0.7968, 0.79. But if I'm rounding to 3 decimal places, this is the third, so this would round up to 0.797. That's what that one will be. All right, let's just make sure we got the good answer. Over here, we would say the natural log of 231, close, divided by the natural log of 7, and I'm going to hit enter, and then I'm going to subtract 2. And I get 0.7968 or 0.797. You get the same thing that way. You don't have to do it both ways, you just have to do it one way, and either one's acceptable. Okay, let's do number 2. Number 2 goes like this. I'm only going to be doing it one way from now on to save time on the video, but just you can always know that you'll get the same approximate answer if you've done it correctly. Okay, 5 to the x, number 2, is 5 raised to the x is equal to 4 raised to the 2x minus 1. You need to first isolate your exponential equation and then apply a logarithm are sort of the steps to follow. When you have two exponential equations and they're isolated with the equal sign in between, that counts as being isolated, and you can apply a logarithm. Last time I did natural log, this time I'm going to do log base 10, or just log. So it goes like this. I'm going to apply a log now. Log base 10 equals log base 10. I could also have used natural log. It wouldn't make a difference. The reason, and I'm restricting you to either this one, log base 10, or log base 8. So we did log base 10 here. Now, why this helps is now we can use logarithmic properties, and the one that's very helpful is the power rule, because this takes an exponential equation and turns it into basically a linear equation. So that's very nice. Let's throw the x in the front and that power in the front. This gives us x times log base 5 is equal to 2x minus 1 times log of 4. Now, this is different than the first one because I have an x on this side of the equation and an x on that side of the equation, and that's what I'm trying to solve for. So I'm going to here distribute log base 4. So again, you can think of this as x times 5 equals to 2x minus 1 times just the number 4. And the steps that you would take to solve this basic equation are the same steps that you would take here. 5x is 8x minus 4 if you distribute the 4. What will I do here? I'll say x times log base 5 is 2x times log of 4 minus the log of 4. And then what I would do over here is we get all the x's on one side. I would subtract the 8x. I'm going to do the same thing here. I'm going to move this x term over here so my x's are on the same side. Now I have what I would do over here is these are just whole numbers, so those easily combine. So that would be negative 3x. I don't really have that luxury when I have natural logs involved. But what we do is a very nice, I would combine these terms if I could. Over here, what we do is we factor out an x, and that gives us 1x. That's a way of sort of combining them. So let's factor out an x, so we just have an x by itself. And we're left with log of 5 minus 2 log of 4 is negative log 4. Basically, we have x times a number equals a number. X times a number equals a number. Divide both sides by negative 3 in this case. Divide both sides by log of 5 minus 2 log of 4 log 5 minus 2 log 4. And that's what x equals to. This is the exact answer. So if I put that in my calculator, I can find the approximate answer. And so I hope my calculator doesn't die. It keeps giving me warnings that it's about to. Negative log of 4. And I forgot to, I'm gonna put parentheses around my numerator. So I'm gonna say parentheses, negative log of 4. I'm gonna close my log argument and I'm gonna close my other parentheses to say that's my whole numerator, divided by, open a parentheses right here to say this is the beginning of my denominator, log, it opens up the argument, 5, close the parentheses to close that argument, minus 2, hit log, it opens up a parentheses for the log argument, put in 4, close the parentheses to close the log argument, put another close parentheses to close the denominator, and hit enter, and I get 1.1918, if it's to 3 places, and it is, I'm going to round this to 1.192. All right, now last one on the sheet, let's do that one. It says to solve this guy, and I'm not going to take as long to do this because I kind of talked through a lot of the steps on the last one. So I'm going to choose, you can either use log base e or log base 10. I'm going to do log base 10 again because I think usually students say do log 10, but you could use either one, it doesn't matter. Okay, for number 3, it goes like this. We have to solve 9 raised to the 3x minus 2 equals 3 to the 6x plus 1. All right, these are not the same base. Okay, that's fine. What they are isolated by an equal sign, so I'm going to apply a logarithm. I'm going to apply log base 10. Log base 10 of 9 to the 3x minus 2 is equal to log base 10 of 3 to the 6x plus 1. Now, I'm going to, now that I've introduced a log, I'm going to use the power rule and throw the powers in the front. 3x minus 2 times the log of 9 is 6x plus 1 times the log of 3. Now I'm going to distribute this number called the log of 9 to both terms. I'm going to distribute log 3 over here. I get 3x times the log of 9 minus 2 times the log of 9 is 6x times the log of 3 plus 1 times the log of 3. Now I'm going to get everybody who has an x in it on one side of the equation and anybody who doesn't have an x on the other side of the equation. So I'm going to subtract 6x log 3. We have 3x log base 10 of 9 minus 6x log base 10 of 3 is equal to, I'm going to add this term over here, 2 log base 10 of 9 plus log base 10 of 3. I will factor out an x here. 3 log of 9 minus 6 log of 3 is 2 log of 9 plus log of 3. I have basically x times a number equals another number. I'll divide both sides by this number. And this is the exact answer for x. I'm going to put that in my calculator and get the approximate answer. So, let's see here. Let's see. Parentheses, 2 log 9 plus 3 log 3. I'm going to close my numerator parentheses and say divided by, open your denominator parentheses, 3 log 9 minus 6 log 3, and it says that I divided by 0. So let me see. Oh, is this a 0? Did I write a bad problem? Hang on. 3 log by 6. This is the same thing as log of 9 cubed minus log of 3 to the 6th. Is 9 to the 3rd and 3 to the 6th the same thing? Wait, 9 raised to the 3 is 729. And 3 raised to the 6th is 721. Wow, I made up a problem where there's no solution because we're dividing by 0. So here, no solution is the answer to that one because we are trying to divide by 0 right there. So there we go. That was kind of a wacky problem. Now the algebra's all sound, and at the end we found out that this is a bad, I'm dividing by 0 here, so that is no good. All right, so that's how that one ends, and that was a crazy ending. Okay.